All right, welcome back. Uh, Covering aircraft fuel systems. Let's move into our next area, fuel temperature control. And on the screen is a fuel temperature gauge. That is a means for testing the temperature of the fuel in the tanks and at the engine, and it's provided on some turbine powered aircraft. During extreme cold, especially at altitude, the gauge can be checked to determine when fuel temperatures are approaching the point at which ice crystals could begin forming in the fuel. This information can be used to determine when it is time to activate fuel heaters if you have them installed. And ordinarily, there's a table that you can reference to see what the various grades of fuel are graded for at or rated for at the various low temperatures. You can see on the screen here they're measuring down to well, 0 is right at the top, negative 20 on the left, and at 9 o'clock is negative 40. So I would presume the last hash mark is negative 60, which that would be pretty chilly. That is Celsius, where 0 equals the point at which water freezes. Free water can appear as water slugs or as entrained water. A water slug is a relatively large amount of water appearing in one body or layer. A water slug can be as little as a pint or as much as several hundred gallons. Entrained water is suspended in tiny droplets. Fuel heaters protect fuel systems that are subject to ice crystals. These devices can satisfactorily deal with dissolved and even entrained water. However, there is little margin for handling large amounts of free water, which apparently in our illustration, a large percentage of the fuel appears to be the free water in the middle part of the jar. To further minimize the ice problem, most jet fuel is treated with an anti icing additive that mixes with the water in the fuel and lowers its freezing point so it will remain in its liquid state. So you're actually, if it freezes at 0 Celsius, you can add an additive, an anti-icing additive that might take it down to negative 10 degrees. Uh, Therefore, it stays in its liquid form and it may end up working itself out of the system as opposed to ice, which is going to clog uh, a lot of the fuel lines. And our most common anti icing additive is Prist. It's a biocidal agent that it kills the scum forming bacteria in the fuel tank. So its main purpose so is two, acts as an anti-freezing agent, lowering the freezing point of the entrained water that is released from the fuel. But it also has some additives so that it will uh, also kill off some of that microbial growth. Here's an illustration of ice on fuel filters. Because turbine engine powered aircraft fly at high altitudes where the temperature is very low, the fuel systems are susceptible to the formation of ice on the fuel filters. A fuel temperature indicator on the flight engineer's panel warns when the fuel temperature is low enough for ice crystals to form in the fuel. I believe we already said that. Okay, one of the questions that'll come up in this area: entrained water in aviation turbine fuel is a hazard because of its susceptibility to freezing as it passes through the filters. What are common methods of preventing this hazard? And you're only going to pick one of the three options, and you know one of them is going to be anti-icing. So that takes us right to C, anti-icing fuel additives and a fuel heater, which um, we'll talk about the fuel heaters. That's an option in all three, and the fuel heaters. Um, that's going to be our correct answer. I could explain a little bit about high velocity fuel pumps or micromash fuel strainers, but that's not really going to prevent the entrained water from freezing. But anti-icing fuel additives like Prist will. It does say most jet transport aircraft also have fuel heaters or heat exchangers, so it is a little more common. A fuel heater, you're thinking of, some sort of heating element that's, placed right below the fuel tanks. You can imagine that that's going to have some issues as far as safety. More so, it actually routes the fuel through a heat exchanger that might actually be in a section that is warmer, and so the fuel that as it passes through the tubes that is in a warm section, not quite exhaust warmth, but something along that nature where you're going to have uh, warm air and air to fuel um, heat exchanger. All right, I see they even say it. So it's either compressor, bleed air, or engine oil. And that'll raise the temperature of the fuel enough that it won't freeze on the filters. So engine oil would be a good example. So you route the fuel through the warm or the hot engine oil, and that'll raise the temperature of the fuel. A typical oral question. What are two reasons Prist is added to the fuel that is used in a turbojet aircraft? Well, we kind of listed those off. Primarily, it's going to be as an anti-icing agent to, lower the freezing point of the entrained water. Second reason is to act as an antibacterial or microbe agent to prevent the formation of scum or other organic materials in the fuel tanks. So Prist does both anti-icing and antimicrobial. Biocidal agent kills the scum forming bacteria in the fuel tank. We got that one. And two, acts as an antifreeze agent. We got them both. True or false? Gas turbine engine fuel systems are very susceptible to the formation of ice in the fuel filters. So what do you say on that one? I would say that's more true than false. Turbine engine, we did read that turbine engine aircraft, typically because they fly at such high altitudes where the air is very cold, it's very susceptible to ice being formed in the fuel filters. And we even saw an illustration of that. So that is true. Ordinarily, these go two at a time, though. All right, why do turbine engine aircraft have fuel temperature indicating systems? Because they travel at high altitude and therefore the ice has a possibility of freezing or having ice crystals form in the fuel filters. And so the fuel temperature indicating system will alert the flight crew, and we saw the example of the flight engineer, and they'll have an opportunity to apply the fuel heater if installed, or otherwise compensate. To allow the crew to determine if the fuel is cold enough to produce a danger of the formation of ice crystals. Fuel heat control panel shown here. It's a 3-engine aircraft. I would imagine the 727. Basically just a toggle switch, turn it on and off. And it does have the fuel temperature gauge as part of the panel. The valve in transit lights. We talked about those a little bit, or are we going to talk about them here? Now, there's one oral question that may ask, what is a valve, or how does it operate? Basically, while the valve is in motion, either opening or closing, the light will come on. It looks like the top light is going to be for the icing. So if the fuel temperature is reaching the point where ice crystals could form, you're going to see those lights come on. The fuel heat switches open or close the valve that directs hot, high-pressure compressor bleed air into the heat exchanger. All right. We also learned that it could be oil. Not into, it wouldn't release oil, but it would probably release fuel into the heat exchanger that is submerged in an oil bath. The fuel temperature gauge on the flight engineer's panel, and the flight engineers are usually, when aircraft flew with 3 flight deck crew members, the pilot in charge, the second in command, and the flight engineer, who's usually seated behind the second in command. These days, because of the electronic systems that we have, the need for a flight engineer on practically all commercial flights is just non-existent. Maybe something for cargo. But for our purposes, that's where the alert is. And when they say flight engineer's panel, this looks like a 727. Here's a nice illustration of a heat exchanger. You can see the fuel in the blue comes in from the right, and it passes through until it gets into the fuel outlet way over here on the left. It passes through this area, which is in the tan, and that appears to be air. So that would be the engine bleed air that is directed through here. So the fuel ordinarily flows through these tubes, but the air doesn't always flow unless you actually need it. The fuel temperature sensor is located here. There's some cooling fins, and there's also, I thought I saw a fin up here also. All air baffle, they call it. Heat from the air enters the fuel, raises its temperature enough to prevent the ice crystals from forming. fuel heaters could also be this heater oil to fuel. We talked about that. So it's either here we have the air, compressor bleed air, and in the darker arrows. And here we have an heater to oil or heater oil to fuel. I'm not saying that correctly. Basically, it could also be used to thaw ice on the fuel screen. So the ice is already formed. It's possible that this fuel heater can actually thaw that ice for you. Probably the fuel is flowing through the top and the oil is flowing through the bottom, and it's not mixed. You're not going to mix the oil with the fuel, but you are going to treat them like an exchange. So they're going to be separately tubed, but it works the same as the air. True or false? A fuel heater operates as a heat exchanger to warm the fuel. That's true. I guess that's the second part of that first question. Statement 2 is also true. It does operate as a heat exchanger to warm the fuel. These heat exchangers may use compressor bleed air or warm engine oil to furnish the heat. Here's a close-up of what the fuel temperature sensor looks like. And you can see there's some threads on the top. Okay, I would say that this clamps into that part of the case that is close to where you want to do the measurement, and then you're probably attaching a BNC type attachment to the end, a type of a cable that goes actually into the flight engineer's indicator panel. When the fuel temperature gets near 0 degrees centigrade, hot compressor bleed air can be directed through the fuel heater to prevent the formation of ice. So we know at 0 degrees centigrade, that's when water freezes. So as soon as you get to that point, you know you're in the danger zone. Question. A fuel temperature indicator is located in the fuel tanks on some turbine-powered airplanes to tell when the fuel may be A. Getting cold enough to form hard ice, B. In danger of forming ice crystals, C. About to form rime ice. So rather than learning all the different types of ice like hard ice or rime ice, we've already been talking about ice crystals many times, so you know that's going to be the answer they're looking for. Yes, and it is. So look for the ice crystals, and it's really another way of asking the same question that we've been covering. What method is used on turbine-powered aircraft to determine when the condition of the fuel is approaching the danger of forming ice crystals? There's our ice crystals word, but this time it's not going to be in the answer. So what is going to be the method to determine the condition of the fuel? Probably some sort of temperature gauge. Yeah, right there. The only answer that even talks about temperature gauge or indicator, and that's C, the fuel temperature indicator. uh, as opposed to fuel pressure, which is not used to detect ice. It doesn't actually detect the ice, it just detects when the fuel is in a condition that there could be ice. Now, it does say that ice crystals on the filter element causes an excessive pressure drop across the filter. And there is that last sentence or paragraph. A fuel strainer differential pressure gauge gives an indication that ice crystals have already formed and are restricting the fuel filter. I see. I should have read the whole thing. Yeah, the question is, when is the fuel in danger of forming ice crystals? Not necessarily how do you detect that ice has already formed. Apparently, a fuel strainer differential pressure gauge can tell you if ice has already formed. So I'm going to be on the lookout now for a question coming up about that. Let's see if they go that deep. True or false? The function of a fuel heater is to protect the engine fuel system from ice formation. I can't see anything wrong with it. It's not like it has multi-functions. That really is its only function. So true. What's this, the second part of it? It is the second part. What is that? An aircraft fuel heater cannot be used to thaw ice in the fuel screen. Well, if you've got ice in the fuel screen, you're going to be turning on your fuel heater anyway. Just the fact that the fuel that continues to go through the fuel screen is warmer, it could thaw the ice that's actually present. That's like pouring hot water on an ice cube. You are going to thaw it. So I would say, since they're saying it cannot be used, I'm going to say that's not entirely true. It may not be effective, but it can be used. So that's a false statement or not true. Which is the correct answer is that it is not true. A fuel heater can also be used to thaw ice that's already formed. It looks like we got a few newer questions here. Fuel heaters are used with fuel systems for turbine engines to prevent what in the fuel from clogging system filters? Can I hear the word crystals in there somewhere? Yes, okay. There's our word, B, ice crystals. Fuel heaters have nothing to do with contamination. And moisture, they're not going to stop the moisture from forming. If anything, they might actually add to the moisture. So ice crystals, clearly the correct answer. Select one means of controlling the fuel temperature on turbine-powered aircraft. Engine bleed air is going to be the option on all of them. So engine bleed air, A, to the fuel filter, B, to the fuel tank, or C, to a heat exchanger. All right, so you're going to actually blow the bleed air through the heat exchanger, not directly on the fuel filter, or certainly not on the tank itself. So it supplies the air, engine bleed air, to a heat exchanger C. All of the fuel that flows to the engine must pass through this heat exchanger. Sometimes you'll see air to fuel, oil to fuel. Um, Basically, the heat exchanger, where is the heat coming from and what's it going to? So the hot air is um, going to the cold fuel to warm it up. True or false? A fuel heater can use engine bleed air as a source of heat. Well, it's actually true. It's mostly used as a source of heat. And the second part of it, a fuel heater can use engine lubricating oil as a source of heat. Not as common, but it can use it. And we did see some examples of that, including uh, the engine oil or lubricating oil to fuel the heat exchanger or valve anyway. We saw the valve, we didn't see the full heat exchanger, or we may have. So it's also true. That might wrap it up. Yes, it does. I've got a review video. It's very short. Um, at this point, I don't see any progress on including those in these course shells. But certainly, if the instructor um, wants to play a review video, here's the timestamp that can be used for your assistance. See if there's any supplemental materials. Yes, there is. 737, they're showing us the fuel temperature gauge in the center with some warning lights, I guess. Illuminated valve position indicators and fuel filter bypass lights. One nice thing is if the fuel filter is getting clogged with ice crystals, it does have a bypass, so the fuel just doesn't flow at all. It just doesn't go through the filter. So in effect, the engine will be running with unfiltered fuel. And you wouldn't want that to continue on as a normal condition. So these red lights will come on if the filter is being bypassed. The biocidal agent that is added to turbine engine fuel to prevent the formation of microbial contamination also lowers the freezing point of any water that condenses from the fuel. So far, it's not terrible. I don't really like any, but I'll take it. B, raises the freezing point of any water. Well, we wouldn't want to really raise it. That'd be in effect having the fuel start freezing at positive 20 degrees. No, we want to lower the freezing point. And let's see, increases the heat energy of the fuel. Interesting option, but certainly not the correct one. So it's A, lowers the freezing point of any water that condenses from the fuel. The fuel in a jet transport aircraft may be heated to prevent the formation of ice crystals on the fuel filtering elements. One method of heat that is not used is A, electrical heating elements. We haven't seen that, so I would say that it is not used. Compressor bleed air, yes, 80% of the time. Engine lubricating oil, yes, 20% of the time. Electric heating elements, 0% of the time. All right, that wasn't too bad. So appreciate you sticking around and looking at those questions with me, and we'll see you on the next one.